In this video, we are going to review how to simplify a rational expression. So to start, I've written 3 steps on the side here that I will be using with each question. The first step is to factor your numerators and denominators. Then we want to state our excluded values. And finally, we will simplify and write our rational expression in the most simple terms. So to start, I have this expression 6x plus 30 divided by 2x plus 10, and I am going to factor the numerator and then the denominator. So 6x plus 30, I see that 6 and 30 both have a 6 in common as a factor, so I can factor that out. And then I'm left with x plus 5 in parentheses. I'm going to do the same thing with the denominator, and I see that 2 and 10 both have a 2 in common. So if I factor that out, I am left with an x plus 5 in parentheses. Now I'm going to take time here to state what my excluded values are. An excluded value is any value of your variable, so in this case x, that makes the denominator equal to 0. I can never divide by 0. This is undefined. So when we're trying to find excluded values, that's going to be whatever value of x, whatever value of x makes our denominator equal to 0. And when we find that excluded value, it just means that it is not part of our solution. So I'm looking at the denominator here, and I want to think what value of x makes this equal to 0. One, I can inspect and just see if I put what number would have to go here to make this equal to 0. And if I can't see it immediately, I can go ahead and just write an equation and say 2 times x plus 5 equals 0. And as I go through and solve that, it will tell me that if x is equal to this, then the denominator will be equal to 0, and that is an excluded value. So my excluded value is x equals 5. So I could have a value of x equals 2, and that's fine. X equals 4, that's fine. But if I have x equals negative 5, I will have a undefined function, and that is not fine. So our final step is to simplify and divide our common factors. So looking at the original, at our simplified version here, I can see that there is a common factor of x plus 5 in the numerator and the denominator. So I can actually cross that out because x plus 5 divided by x plus 5 is just going to equal 1. And if I cross that out, my value remains unchanged. So now I have 6 over 2. I know that 6 and 2 can both be divided by 2, so I am left with 3. That is the equivalent form of this original rational expression. Now, one of the reasons why I like to write the excluded values second and not wait until the end is because if we wait until the end, I can see that I don't actually have a denominator here. And so I don't have any values of x either. And so looking at this, I might think that I don't actually have an excluded value. But I always want to come back to the original problem because that is where I can see what the denominator originally was before I simplified it and see what the excluded values can be. So looking at the original and the simplified version, it's much easier to see our excluded value of -5 in these two than it is in our simplified version. So review the steps here, factor, excluded values, and simplify. And go ahead, pause the video and see if you can solve this problem. All right, my first step is to factor using the difference of squares here. And because a is equal to 1, I am confident that I can factor this using some mental math. So my first step was factor. I'm going to write my excluded values. So values of x that would make this equal to 0 would be x cannot equal -2 or -3. If I have a -2 here or a -3 here, that would make it equal to 0, and I cannot divide by 0. So my last step now is to simplify and cancel my common terms. And I am left with x minus 3 divided by x plus 2, for when x does not equal -2 or -3.